All right, so this section we're going to do everybody's favorite, angular and linear velocity. A lot of students think this is difficult, but hopefully after this video you'll see that it's not difficult at all. All right, so before we get into the angular and linear velocity problems, let's do some practice problems, or some problems on how to convert units, because this is something that's important that you need to know how to do when you're working the angular and linear velocity problems. It'll make your life a little easier. All right, so we want to perform each conversion here. All right, so we want to convert from 30 revolutions per minute to radians per minute. Okay. All right. So before we get started on this problem, if we look at a revolution, so if we have let's just draw a circle here. So if we have a point on the circle, let's put the point right here. It doesn't matter where you put the point. But if you have a point, one revolution is going all the way around one time. That's one revolution. Okay? Now, if you make one revolution, that's 360 degrees. Okay? Or 360 degrees is what? 2 pi radians. Okay? All right. So just remember, one revolution is 360 degrees or 2 pi radians. Whether, the angle can be in degrees or radians. In this problem, we're in radians. So one revolution is 2 pi radians. All right. So if we have 30 revolutions per 1 minute, okay, that's what we're starting out with. And we want to get to radians per minute. So that means we need radians up top and minutes on the bottom. So I have minutes on the bottom, so we're good there. So what I need to do is multiply this, and remember, I need radians on top and I need revolutions to cancel out. So I know what? I know one revolution is what? 2 pi radians. All right. So how can I do that? Okay. So if you look at a number, say like the number 2, if I multiply that number by, say, 3, that is equal to 6. I've changed the number. Okay. If we multiply something times a number, we change it. But there's one number that we can multiply to something that does not change it. So like this one, 2 times 1 is 2. See, if I multiply by 1, I get the same thing back. I'm not changing anything. All right. And that's exactly what we're doing here. We're multiplying this thing here by 1. Okay. Because remember, 2 pi radians in 1 revolution, that's the same thing. Okay? It's like multiplying by 1. All right, so now you can see here the revolutions cancel out, and so I'm left with multiply. That's 60 pi, and that's what? Radians, because the revolutions canceled out, per 1 minute. And so that gives me 60 pi radians per minute. And that's your answer. Okay? All right, so let's look at the next one. I want to convert 120 revolutions per hour to revolutions per minute. So I have 120 revolutions per 1 hour, and I need to convert that to revolutions per minute. So I need revolutions on top, which I have that already, and then I need minutes on the bottom. So I need to multiply by what? Well, I need the hours to cancel out. So I know that what? That 1 hour is equal to 60 minutes. See, I'm getting my minutes. This minutes here, I'm getting that on bottom. All right. And so you can see now that hours cancel out. And so that's going to leave me 120 divided by 60. That's 2 revolutions per 1 minute. Okay. See, I mean, you can look at it like this. That cancels into that, and we're left with the 2. So there's your 2 revolutions per 1 minute. And so that's 2 revolutions per minute. And there's your answer. Okay. All right. So those first two, those were pretty easy. So let's look at this. So in this one, it looks like they both have to change, see, revolutions per second to radians per hour. So I've got 180 revolutions per 1 second. So I need to cancel this out. I need to get revolutions out of the numerator and seconds out of the denominator. So let's just work on them one at a time. All right, so let's get rid of the revolutions. So I know that 1 revolution is 2 pi radians. All right, so that takes care of the revolutions. They will cancel out, and that leaves me with radians up top, which that's what I need. Now let's look at getting rid of seconds. All right, so seconds is on bottom, so I'm going to have seconds on top. All right, and what do we know about seconds? Well, we know that there's 60 seconds in 1 minute. See that? Okay, but I'm still not where I need to be. I need hours on the bottom. Okay, so let's see if I can get rid of minutes. Well, I need to cancel minutes out. And what do I know about minutes? I know there's 60 minutes in 1 hour. And look, if you wanted to, all this that I've written here, you could have written this as 3,600 seconds is to 1 hour. Okay? But what I would recommend doing is, just take it step by step. We know seconds to minutes, minutes to hours. Okay? We know that. So, just take it piece by piece. Don't try to do everything in one shot. I mean, you can, but more than likely you'll end up messing up. So now, to multiply all this out, that's going to give us, so we're going to multiply, well, let's cancel first. So revolutions cancel, seconds cancel, and we've got the minutes cancel. All right, so what are we left with? Well, you can see we're left with radians and hours. And so if I do 180 times 2 pi times 60 times 60, that's going to give me, see, 129,600. Whoop. One more zero. Pi. And that's going to be radians per hour. And there's your answer. All right. So let's look at the next one. So this one, we're looking at 150 feet per second equals, and then we want to change that to miles per hour. All right, so let's see what we've got here. All right, so we've got 150 feet per 1 second. Now, I've got to get rid of feet, and I've got to get rid of seconds. So let's work on the feet first. All right, so I'm going to have feet in the denominator. So what do I know? Do I know anything that relates feet and miles? Well, we know there's 5,280 feet in 1 mile. Okay, so, you might be thinking, well, I didn't know that. Okay, well, now you do. Okay, that's a common conversion there, feet to miles. Okay, 5,280 feet in 1 mile. Now we got to get rid of the seconds. So let's do it again. Let's go from seconds to minutes, minutes to hours. All right, so we need seconds on top because we've got to cancel it down here. So that's going to be 60 seconds is equal to 1 minute. And then, okay, so once again, I need hours. So I need to cancel the minutes down here. So what do I know about minutes? Well, I know there's 60 minutes in 1 hour. And so let's see what all cancels. Let's see, feet cancel, the seconds cancel, and the minutes cancel. And you can see we're left with miles per hour. And so once we multiply all this out, 150 times 60 times 60, and then we divide that by 5,280, we get 102.27, and that's miles per hour. And there's your answer. All right, so all that was on the first problems was converting. Okay, how do you convert from one to the other? That's going to come in real handy when we're doing these angular and linear velocity problems. All right, so let's look at this. If a point is in motion on a circle through an angle of alpha in radians, that's important there. Your angle measure has to be in radians. In time t, then its angular velocity, omega, that's lowercase omega, is given by omega is equal to alpha over t. All right, so what does that mean? Well, look, if you have a circle, all right, and you have a point on the circle, and you've got your angle alpha here, and let's say this point here is traveling around this circle, okay? The point's going around the circle. Well, if you're driving, okay, let's just say you're driving down the road and your position's changing as you're driving down the road. You're going, say, 55 miles per hour. That's the speed that you're driving. Well, what the angular velocity is it's not how fast you're going around the circle or down the road. It's how fast is this angle changing. So see, when this point, once this point gets to right here, you see your angle is now here. Okay, your angle keeps changing as this point goes around the circle. So how fast is that angle changing? It's changing, say this many radians per second or this many radians per minute. Okay, so that's what your angular velocity is. How fast is this angle here changing? What's the rate that it's changing? So let's look at some examples for angular velocity. So we have a helicopter blade is rotating at 400 revolutions per minute. Find the angular velocity in radians per minute for a point on the tip of the blade. All right, now, whenever you're doing these angular velocity and even the linear velocity problems, when you're doing that, write the formula down, okay? Just write it down. So we've got omega is equal to alpha over t, all right? So we're looking for angular velocity. So we need to know the angle and the time. That's what you've got to have to calculate the angular velocity. So we get all of that from the problem here. All right. So what does it tell us? A helicopter blade is rotating at 400 revolutions per minute. Okay. That's in 1 minute it does that. All right. So what's our angle? So our angle alpha, okay, our angle alpha is 400 revolutions per minute. So just remember, we've got a circle here. If you have a point, when it makes 1 revolution, that angle is 2 pi. Okay, remember, 1 complete revolution is 2 pi, 360 degrees or 2 pi. So if it makes another revolution, that's what? 4 pi, 6 pi, 8 pi, 10 pi, and so on. So alpha, if it makes 400 revolutions, that would be 400 times 2 pi, right? Because look, just think about it this way. If you make 3 revolutions, what's our angle? Well, 2 pi is each revolution. So 3 times 2 pi, that would be 6 pi would be the angle. So however many revolutions, you're multiplying that times 2 pi. And so that would be 800 pi. And that's your angle alpha. Okay. Now, we can plug that in. So that's 800 pi, and that is in radians. Okay, that's radians. Now, in what time does it do that? Okay, what time does it do that? Well, it goes 800 pi radians in 1 minute per minute. So that's per 1 minute. And so we add our units. This is radians and this is minutes. And so our answer would be 800 pi radians per minute. And that is your angular velocity. Okay, that's all you've got to do. Just write the formula down and fill everything out. All right, let's look at the next example. It says a typical 22-inch lawnmower blade rotates at a rate of 2,500 revolutions per minute. What is the angular velocity in radians per second of a point on the tip of the blade? All right. So we're looking for angular velocity. That's alpha over t. Now, if you notice the difference in this first problem we worked versus the next one. So they tell us that it's rotating at 400 revolutions per minute. Okay? And they want to know what is the angular velocity in radians per minute. Okay? Down here, they give us the revolutions per minute, just like they did in the previous problem. But the answer, notice it says radians per second. Okay? Now, there's a couple of ways that you can go about doing this. You can convert everything first and then plug it into the formula. Okay? I think the easiest thing to do is, for right now, just disregard that. Don't even pay attention to what they want the units in for your final answer. Don't even pay attention to that. Okay? We're going to pretend like that's not even there. Just find the angular velocity. Okay? Forget about this radians per second for now. Okay? So, first thing we need is what? We need our angle, and we need time. So our angle, it's 2,500 revolutions. So that's going to be 2,500 revolutions. So that's times 2 pi. We're getting our angle, because remember, one revolution is 2 pi, and we've got 2,500. So 2,500 times 2 pi is 5,000 pi. All right. So our angular velocity is 5,000 pi. Okay. And remember, that's radians over. Now, how long did it take it to do that? Per minute. Per 1 minute. All right. All right. So you have the angular velocity now. You found that. Okay. You found the angular velocity. But wait a minute. They want radians per second. Now convert it. You see that? Convert it now. Do we know how to do that? Of course we do. Look, that's what we were doing up here. That's why we did these problems here at the first. So a lot of these problems, they're going to give you the information that they give you. They're going to give it to you in, revolutions per minute or however they give it to you. And then they may want it in different units. Like if they give it to you in minutes, they may want it in seconds, or they may want it in radians per hour or radians per day. Or they could give you revolutions per day or revolutions per year. They could give you that and say, well, what's the angular velocity in radians per second? If they give it to you if they give you revolutions per year, what's radians per second? Disregard what they want the answer in and just find it in terms of what they give you. And then once you find that, then convert it to the units they want. Okay? So now let's convert this. So we need radians per second. So that means we've got to get minutes out of the denominator. So I've got minutes, so I got to cancel those. And what do I know? Well, I know there's 60 seconds in 1 minute. Okay? And so this is going to give me 261.8. And look at this, minutes cancel. So I did 5,000 pi divided by 60, and that is in radians per second. And there's your answer. Okay? So don't try to memorize how each one of these problems were worked. Okay? Just know whatever units they give you, the information they give you to plug into your formula here, whatever that is, find your answer in those units. Then convert it to the units they want. Okay? That, to me, that's the easiest way to do it. All right. Now let's look at this. We've got linear velocity. And look, linear velocity, these problems, they're no different than what we just did with angular velocity. It's just a different formula. That's the only difference. It's a different formula. Okay? All right. So if a point is in motion on a circle of radius r through an angle of alpha radians, important again, notice your angle is in radians, in time t, then its linear velocity v is given by the linear velocity is equal to s over t, where s is the arc length. And you know from previous sections in trig that your arc length is alpha times r. It's the angle times the radius. Okay? Now, to show you what that is, if we have a circle and you have a point on the circle and it's traveling around the circle, well, how fast is that point traveling around the circle? Miles per hour, feet per second, or whatever it is. Okay, that's what you're looking for, the speed that it's traveling around the circle. So that's linear velocity. And remember, angular velocity is how fast the angle's changing. Linear velocity is actually how fast is it traveling around the circle. Okay, so here's your formula for linear velocity. Now, there's also another way that this formula is written that you'll see, and I'm gonna show you that. So if you have your linear velocity, I'm gonna do that in a little bit different color. So your linear velocity, that's s over t. Okay. Now, what is s? S is the arc length. That's equal to, that's the same thing as s is what? Alpha times r over t. You see that? And then if we split this fraction up, that's alpha over t times r. Okay? Now, what is alpha over t? Let's go back up here. Alpha over t is your angular velocity. So we can write this as omega times r. So the other way that you may see the formula written, your linear velocity is your angular velocity times the radius. Okay, so what'll happen is in some problems they may say the angular velocity is this and the radius is this. What's the linear velocity? Well, if that's the case, if they give you the angular velocity, just plug it into this formula. Okay, otherwise you'll need to plug it into this one. Okay, so that's the two you need to remember. But, like I said, you can remember just one of them and get the other one. Okay, you can, this also works the same way as, we started with s over t and we wrote s as alpha times r, split it up and got omega times r. But this would also work going back this way. You can rewrite omega as alpha over t, and then you've got alpha times r, and alpha r is s over t. Okay, so if you know one of them, you can get the other one. All right, so let's look at this example here. It says a propeller with a radius of 1.2 meters is rotating at 1,400 revolutions per minute. What is the linear velocity in meters per minute for a point on the tip of the propeller? All right, so let's see what we've got here. So we've got the linear velocity is equal to s over t. Write the formula down. This is the same thing that we did with angular velocity. It's going to be the same thing. So just find what you need here to plug in. Okay? All right. So first, let's find S. Okay? S is alpha times R. Okay? So let's look at this. Well, do we know alpha? Well, yes, we know alpha. It says it's rotating at 1,400 revolutions per minute. Okay, 1,400 revolutions per minute. So alpha is equal to what? 1,400 times 2 pi. Remember, alpha is your angle. So remember, one revolution is 2 pi. 2 revolutions would be 4 pi, 6 pi, 8 pi, and so on. So the 1400 times 2 pi, that's going to be 2800 pi. And remember, that's radians. And do we know R? Yes, let's see. R, they tell us, is 1.2 meters. Okay. So S would be what? 2800 pi times 1.2. Okay. That's all S is the arc length. So let's see, we got 2800 times 1.2. That is 3360 pi. So that's S. Okay, that's S. And so we're going to get V is S, which is 3360 pi. And that is what? Okay. All right, think about what that is. This is what? Meters, right? Okay, so remember, arc length, that's the distance. So look at this. So if we have a point here and it travels around the circle to here, this length here, that's a distance there. Okay, well, the radius is in meters, so this length here, that's going to be in meters. So there's your arc length, 3,360 pi meters. Now, how long did it take it to travel that distance? Okay, how long did it take it to travel that distance? Well, per 1 minute, right? So that's per 1 minute. And so what is our answer? Well, it's actually just this, right? 3360 pi meters per minute. And if you wanted to multiply this out, that would be 10555, and we'll just say 0.8, okay, meters per minute. And there's your answer. Okay. All right, let's take a look at another one. What is the linear velocity in miles per hour of the tip of a 22-inch lawnmower blade that is rotating at 2,500 revolutions per minute? All right. So we're looking for the linear velocity. That's S over T. So let's get S. That's alpha times R. All right. So what do we know? Let's see what we've got. Let's get alpha. So alpha, that's what? 2,500 revolutions, okay, per minute. So that's going to be 2,500 times 2 pi, right? And so that's going to be 5,000 pi. That's our angle. Now we need R. Well, R would be what? 11, that's 11 inches, right? This is radians. Now, how do I know the radius is 11 inches? Well, it says a 22-inch lawnmower blade. Okay, so the lawnmower blade is 22 inches long. That's from tip to tip. So we need the radius, that would be halfway. So half of 22 is 11. And so the arc length is 5,000 pi times 11. And let me see what that is. That is 55000 pi. All right, 11 times 5,000 is this, and then times the pi. And what is that? That is inches, right? Because that's the radius is inches. Okay, so that's the distance it travels. Okay. All right. So we've got V is S, which is the 55,000 pi, and that's inches. And how long does it take it to do that? Okay. Well, it did that many revolutions per minute, per 1 minute. Okay. Now, notice during this whole time, not once did I think about what they wanted the final answer in. Okay. All I did is I found the linear velocity based on the units that were given. Okay. Now, let's go back and find out what they want the units in. So what is the linear velocity in miles per hour? Okay. Miles per hour. All right. So let's work on inches. Okay. Let's work on the inches. So I've got to get rid of inches out of the top, and I need miles in the numerator. Okay. So what conversions do I know? Well, right off the top of my head, I know inches. Whoop, I'm sorry about that. Okay. So what do we know about inches? Well, we know that there's what? There's 12 inches in 1 foot. We know that. Okay. But I'm still not to miles. So do we know anything relating feet and miles? Yeah, we did that. That was an example we did at the first. Well, I know that feet has to go down here because that has to cancel out. So I know there's 5,280 feet in 1 mile. Okay. So look what I've done. I've gotten miles up here in the numerator, and that's what I needed, miles. But what do I need in the denominator? I need hours, and I'm in minutes. So I need minutes to cancel out down here. So I need minutes in the numerator because it's got to cancel with the minutes in the denominator. And I know there's 60 minutes in 1 hour. Okay? So after multiplying all this out, multiplying this times 60, and then dividing that by 12, and then dividing it by 5,280, I'm going to get 163.6 miles per hour. Let me go ahead and cancel all this out so you can see. Inches cancel, the minutes cancel, and the feet cancel. And you can see we're left with miles per hour. And so this is your answer. Okay? All right, last problem here. Now, this problem here, it says, what is the linear velocity in miles per hour of a point on the equator? So we've got a point on the equator of the Earth, and they want to know the linear velocity. Okay? So you're looking at this, and you're probably thinking, well, they're not giving us enough information. And you're right. Okay? So what they're doing here is they're assuming that you know this. They're assuming that you know the radius of the Earth, and they're assuming you know how fast it rotates. Okay? Now, do you know that off the top of your head? Probably not. Did I? Not really. Okay. But after looking it up, you can find that a point on the equator has an angular velocity of pi over 12 radians per hour. Okay. Okay, so if you didn't know that, you know it now. Okay. And then the radius of the Earth. Now, when you look up the radius of the Earth, you might see some different some different measurements for the radius, but I got one of them, and it's 3,950 miles. Okay. All right. So this is some information that would have been nice if they would have given it to us in the problem, but they didn't. They just, okay, we assume you know this. Okay. Do you? Probably not, but now you do. Okay. And if you're working a similar problem, I would suspect that they might give that to you, or, you can go look it up on the internet. You can Google it. All right. All right. So the linear velocity. Now, remember, linear velocity, what we've been using so far is this S over T. Okay. But remember what we did up here on linear velocity. This was the formula they gave us, but remember how I showed you could get that. The linear velocity is also the angular velocity times the radius. And if you look down here, that's exactly what we have here. We have the angular velocity and we have the radius. So I'm going to use that formula because I'm already given that information. Okay. So this is going to be pi over 12, and that's radians per hour. And I'm multiplying that times 3,950 miles. Okay. Now, once I multiply all this together, pi times 3,950, and then divide that by 12, I'm going to get about 1,034 miles per hour. And so that's how fast a point on the equator is traveling, okay, as the Earth is spinning. All right. So you might be wondering what happened to the radians there, because my final answer, miles per hour. Well, the angular velocity, okay, we wrote that as radians per hour. Okay, the radians, they're omitted from the answer because the radians is just they're just real numbers. Okay, they're real numbers, radians are. So we can omit the radians, and that just leaves us with miles per hour. Okay, so hopefully this video helped. Okay, don't make this more difficult than what it is. All you're doing, whether they're asking you to find angular velocity or linear velocity, it doesn't matter which one. Write the formula down. Find all the values that you need to plug into the formula. And when you're plugging these values in, use the units that they're giving you. Okay? Use the units that they're giving you. And find that answer in those units that they give you. Then look and see what units they want the answer in. Then convert it once you find the answer. Okay? So hopefully this helped. Check out my other videos. Give me a like, share, and subscribe. And thanks for watching.